The question number 106, the relationship between the number of turns, voltages and currents in primary and secondary windings of a transformer. The options are given below, that is N1 by N2 is equal to V1 by V2 is equal to I1 by I2. The second option is N2 by N1 is equal to V1 by V2, that is equal to I2 by I1. The third option is N1 by N2 is equal to V1 by V2, that which is equal to I2 by I1. The fourth option is N1 by N2 is equal to V2 by V1, that is equal to I1 by I2. In transformer, if the number of turns increases, then voltage is also increases. But if the number of turns increases, then the current is reduces. So we can rewrite like this, that is N1 by N2, where N1 is the number of turns present in the primary winding and N2 is the number of turns present in the secondary winding, which is equal to V1. V1 means the voltage which is present in the primary winding, and V2 is the voltage which is present in the secondary winding. That means N1 is directly proportional to V1. That is N1, that means number of turns in primary winding increases, then voltage which is present in the primary winding is also increases. Similarly, if the N2 voltage increases or decreases, then V2 voltage is also increases or decreases. But number of turns is inversely proportional to the current. That means the N1, that is number of turns in the primary winding increases, then in primary winding the current is decreases. So it is inversely proportional. From this we have second option, the third option is the right one, that is N1 by N2 is equal to V1 by V2, that is equal to I2 by I1. The question number 107, that is the cells are connected in parallel when more dash is required. The options are given below: current, voltage, resistance and capacitance. When you connect cells in parallel, that is say V1, V2, V3, then across the terminal the voltage will be same, that is V, but only current, that is I1 across the V1 and current I2 across the V2 terminal and current I3 across the V3 terminal is added up. That means I is equal to I1 plus I2 plus I3. So the maximum current will be flowing across the terminal when voltages are same in parallel combination and current will be added up. So when cells are connected in parallel, the voltage is constant and current is added up. From this we can conclude the option 1 is the right option. Similarly, if you connect the cells in series combination, here the current I is the same, only voltages across the terminal is added up. So the total voltage becomes V is equal to V1 plus V2 plus V3. So when cells are connected in parallel, voltages are same, that is V1 is equal to V2 is equal to V3 is equal to V, and current is added up. But when cells are connected in series, the current is same but only voltages are added up. Then battery, it is the combination of cells. The question number 108, the resistance R of a conducting material is. The options are given below. The first one is R is equal to rho A by L, and second option is R is equal to rho L by A. The third option is R is equal to AL by rho, and the fourth option is R is equal to A divided by rho into L. If we consider a conductor, where the length of the conductor is denoted by L and A denotes a area of that conductor. According to the resistance law, that is R is directly proportional to length of the conducting material and it is inversely proportional to the area of that conducting material. If we rewrite this equation, that is R is equal to rho L by A, where L is the length of the conducting material, where A is the area of the conducting material and rho is the resistivity of the material. Resistivity of a material, and it depends on the nature of the conducting material and its unit is ohm meter. So the right option is second one, that is R is equal to rho L by A, where resistance, its SI unit is ohm. The next question, that is 136th question, that is when three resistors of values 10 ohm, 20 ohm and 30 ohm are connected in parallel, then their effective resistance is. The options are as follows. The first option is 5.46, the second option is 60 ohm and the third option is 0.183 ohm and the fourth option is 6 ohm. From the question, we have to connect three resistances in parallel. That is 10 ohm and 20 ohm and 30 ohm. These three resistors are connected in parallel. We have to find out the effective resistance across these parallel terminal. For that, we have one formula, that is 1 divided by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We know the R1 value, that is 10 ohm, that is 1 by 10 plus 1 by 20 plus 1 by 30. Now we can find out the LCM for 10, 20 and 30. We can get the LCM as 60, that is 60. For 6, 23 is a 60 plus 32 is a 60, that is 11 by 60 ohm. If you solve 11 by 60, we can get, this is for 1 divided by R effective, but we have to take the reciprocal for R effective. That means R effective becomes 60 by 11. If you solve this equation, you can get 5.46 ohm. From the following option, the first option, that is 5.46 is the right answer. We can find out the effective resistance for parallel combination by doing the other method, that is R effective is equal to R1 into R2 into R3 divided by R2 into R3 plus R1 into R3 plus R1 into R2. We know the value of R1, R2 and R3. The R1 value is 10 ohm and R2 value is 20 and the R3 value is 30 and R2 value is 20 into 30 plus R1 value is 10 and the R3 value is 30 plus the R1 value is 10 and the R2 value is 20. If you multiply 10 into 20 into 30, you get 6000 divided by, if you multiply 20 into 30, you get 600 plus 10 into 30, you get 300 plus 10 into 20, you get 200. By adding the denominator, you get the value as 1100. If you cancel 00, that means you get 60 by 11. If you solve by using the calculator, you can get 5.46 ohm. The question number 137, that is, in a pure capacitor, the current leads the voltage by, the first option is 90 degree, the second option is 180 degree, the third option is 45, and the fourth option is 360 degree. In order to solve this, we consider a circuit diagram having a AC source and the capacitor. AC source, when you give a AC source to the capacitor starts charging, but at t is equal to 0, the current flowing through the capacitor will be maximum. That is, it can be shown by using the waveform also. At t is equal to 0, the current will be maximum. That means when you give a AC source at t is equal to 0, the current flowing through the capacitor will be maximum, but the voltage across the capacitor is 0. When time goes on, the capacitor starts charging. That is, the voltage across the capacitor starts charging. When it charges up to the maximum value of AC source, that is, suppose if you give a AC source of 5 volt, then it will charge up to the 5 volt. Then after that it becomes discharging. So the capacitor starts discharges. Similarly, at t is equal to 0, the value of a current is maximum. From this, we can conclude that at t is equal to 0, the current leads the voltage by 90 degree. So the right option is first one, that is 90 degree. The question number 138, for a sine wave, the alternating voltage is, the options are given below. The first option is AV is equal to 1.11 EM. The second option is EAV is equal to 0.707 EM. The third option is EAV is equal to 0.637 EM. The fourth option is EAV is equal to 1.11 IM. Before solving this, first we have to know the average voltage for a sine wave. If you consider a sine wave, it has positive half cycle and the negative half cycle. If we find out the average voltage for a full cycle sine wave voltage, then it will become a 0, because suppose if we consider for positive half cycle, the maximum voltage is 5 volt, then for negative half cycle, if its minimum voltage is minus 5 volt, if you take the average of 5 volt and minus 5 volt, you can get 0 volt. So for a full cycle sine wave, the average voltage is 0. So we have to consider only it may be a positive half cycle or a negative half cycle. For only positive half cycle, we can calculate the average voltage. For sine wave, the equation is like this: E is equal to Em sin theta t. But we have to integrate from 0 to pi, because we are considering only a positive half cycle. If you integrate from 0 to pi interval, this is the equation for finding out the average voltage for half cycle. For full cycle, the average voltage will be 0. So we can consider for only a positive half cycle, and we are integrating from 0 to pi. So we can get 0 to pi. The integration is from 0 to pi. E d theta is divided by pi by 0. If we put E value in the equation, then you can get E value is Em sin theta t divided by pi by 0. We know that the integration of sin theta is minus cos theta. So, Em minus cos theta and pi by 0 divided by pi minus 0 is pi. So, average voltage can be calculated as, you can take minus out of the bracket, then it becomes minus Em cos of pi minus cos 0 divided by pi. That means EAV is equal to minus Em cos pi value is minus 1 and cos 0 is 1 divided by pi. That means EAV is equal to minus Em into minus 2 divided by pi. Minus into minus plus, therefore we can write like this, 2Em divided by pi. If you calculate by using calculator the value of 2 divided by pi, we can get EAV is equal to 0.637 into Em. So, according to this, from the option, the third option is the right answer, that is EAV is equal to 0.637 into Am. The question number 139, dash law of electromagnetic induction provides relationship between change in the magnetic flux and EMF induced in a conductor placed in a magnetic field. The options are given below. The first option is Coulomb's law, the second one is Faraday's law, the third one is Lenz's law, the fourth one is Kirchhoff's law. But the right answer is Faraday's law, because whenever a conductor is placed in a magnetic field, then EMF is induced in a conductor, because magnetic flux linked with the coil changes, then the EMF is induced in it. That is given by E is equal to N into d pi by dt, where N is the number of turns, but in this diagram we are using only one turn. So, here N is equal to 1, where d pi by dt is the magnetic flux. It will produce when a conductor is rotating or by wearing the magnets. The third option is Lenz's law. The Lenz's law can be, it gives the direction for the magnitude of the EMF and the magnetic flux linked with the coil. That is, it always opposes the magnetic flux linked with the coil, so that the Lenz's law gives the direction of EMF induced in a conductor and the magnetic flux linked with the coil or conductor. It is always opposite to that of magnitude of the induced EMF. Then Coulomb's law. Coulomb's law tells the it always tells the electrostatic force between the two static charges, that is Q1 and Q2, separated by the distance d. Then the electrostatic force of repulsion or attraction is directly proportional to the magnitude of the Q1 and the magnitude of the Q2. That means the product of Q1 and Q2, and it is inversely proportional to the square of the distance between Q1 and Q2. Then the fourth option is Kirchhoff's law. Kirchhoff's laws, in Kirchhoff's laws we have two laws. First one KCL. In KCL, the summation of current is always 0. In KVL, the voltage drop across the mesh or around the mesh is always 0. Question number 140, that is quality factor of a coil is, the first option is XL divided by L, the second option is XL divided by C, the third one XL by R, the fourth one R divided by XL. They are mentioning that the quality factor of a coil means inductor, that is inductance. So the quality factor of inductor or inductance is given by inductive it is the ratio of inductive reactance to the resistance. Inductive reactance is nothing but XL, resistance is R. So quality factor of a coil is given by, it is the ratio of inductive reactance to the resistance. Similar, so the option is XL divided by R. It is the right option. If you consider it for capacitor also, for capacitor the quality factor is given by capacitive reactance, it is the ratio of capacitive reactance to the resistance. For that, capacitive reactance is nothing but XC divided by R. This is for quality factor of a capacitor and this is for quality factor of a coil, or it is nothing but inductance.